7th grade, changing dimensions, you have to think about it a little bit, but it's not too bad. This will be one where I want to see your good and hard effort, and I will reward you for that, so I don't want you to overly stress. We're going to learn to find the volume and surface area of similar three-dimensional figures. So similar means they're alike, but they don't have to necessarily be the same size as long as they're the same ratio. Recall that similar figures have proportional sides. The surface areas of the similar three-dimensional figures are also proportional. To see this relationship, you can compare the areas of corresponding faces of a similar rectangular prism. So, we're going to look at just this front face and that front face. So this one you can see is 1, 2, 3 by 5. 3 by 5. This one, 2, 4, 6. 2, 4, 6, 8, 10. The sides grew by a multiple of 2. Their areas, this one being 15, this one being 60, also grew by a multiple of 2. So let's see what the book has to say about that. Okay. Area of the front of a smaller prism. Area of the front of a larger prism. All right. So, (15 times 2 squared). So we know that 6 times 10 was 60. But what they're showing you here with these steps, we took 3 times 2. We took 5 times 2. So instead of taking it times 2 like we took the edges, we took it times 2 twice. So when we double edge lengths, we actually multiply the surface area by 4. Remember the 15? Remember the 60? Remember the 3? Oh, this is times 2. This is times 4. This was times 2 as well. Since each one was taken times 2, the area, or surface area, grows by 4 when the items double. Now, if the surface area grows by 3, it'll be 3 squared. If the surface area goes by times of 4, it'll be 4 squared. Whatever the side lengths change by, the area will change by that number squared. That's what they're showing us today. A scale factor is a number that every dimension of the figure is multiplied by to make a similar figure. So the scale factor, which is 2 in this case, is squared. If the scale factor were 4, 4 would be squared and it'd grow by 16. We'll show you what we mean. The area of the front face of the larger prism is 2 squared times the area of the front face of the smaller prism. This is true for the entire surface area of the prism. So, the surface area of a box is 35 inches squared. What is the surface area of a similar box that is larger by a scale factor of 7? So the sides would grow by a scale factor of 7. But remember, there's 2 sides that you have to multiply to get that surface area of a box. Okay? So, the surface area of the box is 35. So we would actually take 35, times 7, and well, let's just let them show you. 35 times 7 squared. Evaluate the power. Do the multiplication. And squaring having the 7 be the multiple of each side, it's actually going to be much, much larger of a change for the surface area. So, the surface area of a box is 1,300 inches. Find the surface area of a similar box that is smaller by a scale factor there. We still do the same thing. 1,300 times the scale factor squared. 1/2 times 1/2 is 1/4, which really means we're dividing by 4 because we get 1,300 over 4. We do those divisions, all right? So that's 2. That becomes 6. Okay, 5, 0. We can get rid of that other 2. That becomes 3, 2, 5. 325 is our new one because we squared our scale factor and then multiplied, which ended up in division. Let's see if they came up with the same item, okay? They did what I did. 1/4, because that's 1/2 times 1/2. 325. So, the surface area of a box is 50 inches squared. What is the surface area of a similar box that is larger by a scale factor of 3? Stop! Do the math! Welcome back from redoing the math. 50 being the surface area. Scale factor is 3 squared. So 9 times 50. 450 would be my new surface area. Let's see if we did it right. All right, it looks like we did do well. Again, try. We're going smaller, but we still do the same thing with scale factors. So pause, try, and we're back. So 1,800 is the surface area we started with. 1/3 is the scale factor. Squared. So it would actually be 1/9 times 1,800. I'm going to put it over 1. Changes nothing. 1,800 divided by 9. I know I can reduce, divide by 9. This one divided by 9 is 200. 200 is my new answer. All right. A very big change with the scale factor there. All right. They have the same equation. We evaluate the power. 1/9 times that. When we do that multiplication, 200 is our answer. And we go. The volumes. So, surface area, if you need a final reminder, you take the original surface area and you take it times the scale factor squared. So the original surface area times the scale factor squared, that is for surface area. Scale factor squared for surface area. Volume, which is what we're working on now, will be even more different. I bet some of you have already figured out. Surface area is feet squared. We squared the scale factor. Volume is cubed. We cubed the scale factor. We take 1, 2, 3 numbers. All right? Look at each number. 6 for this one, 3 times 1 times 2. Each side grew by a factor of 2. Watch this. 4 times 6 times 2 would be 8. That'd be 48. 6 and 48. That grew by more than 2. How much more than 2? Well, we'll see. All right? The scale factor was 2 for each of these. 2 times 2, 3 times 2, 1 times 2. So if we look at those red 2's, 1, 2, 3 of them. 2 to the third power, or 2 cubed. 6 times 2 cubed. For volume, scale factor cubed times the original volume will get you your answer. And that's what it was. So, you can see that here. The original volume was 28 feet cubed. What is the volume of a similar pool that is larger by a scale factor of 4? Times the scale factor. For volume now, we cube it. For surface area, since it's feet squared, you square the scale factor. For volume, since it's like feet cubed, you cube the scale factor. That's an important thing. You remember that? You've got this easy. 4 cubed is 64 times 28. I have to do my math off to the side. $1,792. Quite a change in pool size here. Let's make sure we did do this correctly, and it would be feet cubed. So, the unit tells you what to do. Volume is feet cubed. I know I take the scale factor and cube it. Surface area is feet squared, so I know I take the scale factor and square it. Important. Okay? We're doing good so far? Hey, they got the same answer. And it said estimate. I'm fine with you leaving it as a round number. Don't worry about doing the estimate part. This is good. All right. The volume of a small hot tub is 48 feet cubed. All right. Volume, so that was cubed. We know the scale factor is 2 from what they told us. So we cube the scale factor, which is 8 times the 48. All right. I'm going to do it over here just so I don't screw things up. All right. 64, 32, 38. All right. So 384 is going to be our new volume of that. Volume is cubed, so we cube the scale factor. Okay. They did get 384. Remember, we don't have to do the rounding. I'm happy with the straight math. All right. Now, the sink in Kevin's workshop measures 16 inches by 15 inches by 6 inches. All right. Another sink with a similar shape is larger by a scale factor of 2. There are 231 inches cubed in 1 gallon. Estimate how many more gallons the larger sink will hold. All right. So, if 1 gallon is that much, it's going to be bigger by a scale factor. It's going to be bigger by 8. My suggestion, since this was 8, we can know that by doing it. But let's walk through their problem. All right. Understand the problem. All right. So, we're probably going to need to find 16 times 15 times 6 to find the volume of the smaller sink. All right. So, this is also an important number. You can write an equation that restates the smaller sink. All right, a scale factor of 3. So volume of the smaller sink times the scale factor of 3. Okay? Volume of the smaller sink. Okay? Volume of the bigger sink. Okay? Now we want to know the difference of them. And they got that. Notice they took this volume that was the original one. Scale factor was 2 cubed. So this times 8 gets us 11,520. Now we need to know what's the difference between them. All right. Oh, we have to convert into gallons. All right. They told us that. So 1,400 is about 6 gallons. This is about 50 gallons. So we can see it's a difference of, if we subtract, 44 gallons. I was going to subtract these two numbers first and only do one conversion. And if we do that, we will get the same answer. All right? So then we get a 44-gallon difference. We look back. We have that. Oh, excuse me. We look back. My apologies there. We've done one of these, and I'm butting up to my 15-minute time limit. So we're more than welcome to try this one, but I'm going to go a little bit faster. This is by a scale factor of 1/2. All right, another bathtub with a similar one. There are 231 inches in a gallon squared. So we do all these same things that they did. All right, we're going to come to this page where they show us the work. All right, so the bathtub holds that many inches cubed of water. The smaller bathtub, because we did 1/2 cubed, which would be 1/8, holds that much water. Okay? They're going to convert both. 172 gallons versus 22 gallons. Hopefully we're only bathing a baby. All right? We get a 150-gallon difference. All right? Do call me, but the big thing, get the area of one, or volume of one, get the volume of the other. You can find the number of gallons, and then you subtract them. Or you can subtract these two, then convert them to gallons. It works. All right, guys. We'll look at back. And there you can stop and see what it says. And you're ready for the lesson. Do your best. I will give you credit. I know this is a difficult one.